Hi, everyone. My name is Virag Mody. I want to thank all of you for taking the time to attend this talk. I know all of us have busy schedules, so on behalf of everyone at Gravitational, thanks for taking the half hour. Some quick administrative stuff before we really get into it. The title of this talk is How to Securely Access Compute Resources in Cloud Environments. Um, and for the bulk of this talk, we'll be talking about this topic at a conceptual level. But if you do stick around towards the end, there's going to be some type of sort of applied demonstration with SSH certificates. Um, Again, my name is Virag Mody. I am a technical writer for Gravitational. Gravitational is an open source company. We have two tools, both of which are open source. The first is Teleport, which provides secure access for developers that doesn't get in the way, and has inspired much of this topic, as well as Gravity, which is an application deployment tool for deploying into restricted, regulated, or remote environments. So the first thing I'd like to do is define our topic a little bit more. When I wrote this title initially, it kind of just seems like a word salad of um, buzzwordy type stuff. So why don't we narrow down the scope and really figure out what we're going to be talking about here. So first thing is secure access. What do I mean by secure access? I just mean any type of sort of reliable way to authenticate and authorize, right? So know who is accessing this resource and what are they allowed to do. And authentication authorization isn't new by any means, right? Like even in the world of networking, we've had passwords for decades. But the context in which I'm talking about secure access is authenticating and authorizing against multiple data points, right? Lots of information, not just um, this string of characters. And we'll talk a little bit about where that information comes from and how it can be used. The next segment is what is compute resources? Well, that's just any infrastructure resource that has like some type of processing capability. So in cloud environments, most of this is virtualized. We're talking about servers, clusters, applications, databases. But there's also that hardware element, right? You have your desktops and any other sort of devices that may be part of your network. And then finally, cloud environments, which seems like the most self-explanatory, right? We're talking just hybrid multi-cloud VPCs. But more broadly, I'm talking about any sort of elastic environment that is focused on providing high availability and has resilient architecture. So another way to say how to securely access compute resources in cloud environments is how to authenticate and authorize access to elastic infrastructure. Um, so how do we know this is a problem, right? Like, how do we know that I'm not just trying to sell you on something? I'm not just some snake oil salesman. Well, I think there are two trends that are causing this challenge, right? So the first is abstraction, second is decentralization. And I think this image by Gartner on the screen really captures this well, right? So you have all these different X as a service hosting solutions that have taken all these different elements of the IT stack, compartmentalize them, and then have using microservices and orchestration have abstracted them so that you can use some type of like hosting solution on some you know server located in God knows where. Um, and so you have this like extreme sense of abstraction that lets us move at very quick speeds and do more than ever, but it comes at a cost. And similarly with decentralization, like I said, you are using multiple data centers around the world. If you have high availability, then you might be spinning up, um, if your West Coast servers go down, you might need to spin up your East Coast servers. And God forbid you're using like edge devices, right? And then you've expanded um, your network by orders of magnitude. And while this problem, while these trends in and of itself isn't really a problem, it isn't really a cause for concern. I think the way that we enforce access policies, they weren't designed to be compatible with this type of ephemeral infrastructure. So it's not really it's not just the way we access it, but it's also the way that we enforce that access. And nothing is more exemplary of this than how much we rely on networks for this exact purpose, right? So we rely heavily on networks to distinguish between who is a trusted actor and who is a non-trusted actor in our system. And when I talk about networks, I like to think about this concept of the map is not the territory. So what does that mean? Um, well, it means the map is not the territory, right? The map is an abstraction. It is a representation. It is a substitute of the territory. And similarly, a network is an abstraction of the thing itself being user behavior or behavior as a whole. It does not always represent the behavior in its entirety because it is an abstraction. It is a substitute. Um, and so when we look closely at what we're asking the network to do and what it is actually capable of doing, we start to see some incongruencies. An example that I like to use is the fact that infrastructure is no longer static, right? It's fairly dynamic. And so previously, with the network, we were using these substitute variables as placeholders for behavior. We were using IP addresses and ingress ports and all these different types of things that would be a substitute for what was actually going on in the system. Um, but nowadays, those variables are constantly changing, right? We have dynamic infrastructure. And so for the network to keep pace with what's going on, in the territory, in the system, um, there needs to be this constant update of firewall rules, routing rules, API rules, access control lists. And you can automate that as much as possible, but there's always going to be a lag. There's always going to be a delay of what your network is telling you is going on and what is actually going on. And that doesn't make network security irrelevant, right? Like if anything, I think networks are going to become even more important as like cloud computing, continues to move into adolescence and edge computing starts to become a thing. But the processes of authentication and authorization need to happen elsewhere. So that brings me to this slide. This is arguably the most important slide of the deck because it answers the question of how do you access compute resources in cloud environments in a secure manner? And the answer is to separate the processes of authentication and authorization and let the resources themselves enforce the access policy. So how do we go from this type of model to something that looks more like this? Um, well, that's why we have these four principles. And this is, again, the meat of the presentation. This is why it's so important. These four principles are the principles that we've built Teleport on, right? They're the principles that we believe are required to secure access for modern infrastructure, for modern environments. So the first and arguably the most important principle is to base decisions on identity and not secrets. Another way to say that is to grant access based on who and not the what. And so why is that the case, right? I mean, like we've been using secrets for, again, decades now. Why the change? Well, I see secrets as having two big issues. The known issue, right, the one that all of us know is that if a secret falls into the wrong hands, it can be used maliciously and cause, some type of like irreparable damage. But the lesser known weakness of secrets is the fact that a secret isn't a reliable source of authentication. It isn't a reliable form of authentication. Now, originally, secrets are meant to be a one-to-one mapping of the person that is supposed to hold the secret, right? You issue a secret to a person, and that's it. But obviously, we know that's not the case, right? Secrets are shared all the time. And so when a host is presented with a secret that it is validated to use and to authorize for, the person that is presenting that secret is not always the person that that host is supposed to expect. And so just by dint of presenting the secret, you've both authorized and authenticated in the same step. And that's not good, right? And that's what brings me to identity, because identity has a lot more information that you can authenticate against. It is a much richer profile than a secret, than just a random string of characters, which is what I was talking about before when we defined secure access. So how do you do that? Well, you need an identity store. You need a centralized location where you can reliably source identity information that is accurate, that is truthful, that is up to date. And so if you're an enterprise, you might be using an identity provider like Okta, like Active Directory. If you're more into open source solutions, you might be using Keycloak, you might be using Glue. But the point is, all those applications take the burden of authentication off of the resources, right? Off of the network. Because you're now able to outsource the process of authentication to this entity that is tasked with that exact objective, right? It contains all of the identity information. And so it is the best way to authenticate against. And there's also some advantages for authorization as well. It's not, it's not just authentication, which we've now separated into its own sort of process. The identity information can also enforce more authorization controls, right? So with identity, you can prescribe certain groupings, certain roles, certain permissions associated with that identity, right? So like interns, SREs, sysadmins, things like that. Those identities all have their own set of variables, their own set of identification information. And so similarly, you can create these very granular enforcement policies that derives its information from this identity information, right? So you can say very specific things like developers aren't allowed to access production environments after working hours. That's not something you can do with a key. That's not something you can do with a secret. You need to know identity for that. So the next point is make it easy to use, right? The theme of this conference is DevSecOps. So what's more DevSecOps than having some type of security measures that developers actually like to use? And that's not BS. I mean, we've had users, like teleport users, come to us with feedback saying that they enjoy using our product because it's easy for them and they understand the security implications involved. And what's important to know and recognize and incorporate is the fact that developer teams are busy. They move quickly. They have multiple deadlines. They push dozens of updates in a day. And so if you make it difficult for them to actually use the tools they need to do their job, they're going to create backdoors, right? They're going to hard code secrets into applications. They're going to generate a private key that you don't know about. And so even if you are the most well-intentioned and have the strictest security controls in place, if those controls are complicated or inconvenient, you're inevitably going to create a less secure state. So the second principle, just make it easy to use, right? Make it developer friendly. The next point is don't trust private networks. Just assume that there are no private networks. Assume that there are only public networks. And while that may seem like a drastic point to make, I don't think it's too far from the truth. Because nowadays we're exposing our private networks more and more to the public domain, to the public internet, right? We have all these like API, X as a service, public cloud driven applications that we all use. And so more and more, we're increasing the surface area of our internal networks that are exposed to the public. And so that makes it more difficult to sort of assume that we can distinguish between who is public and who's private, right? Who is allowed to enter our system and who is not allowed to enter our system. And so if you get away with this idea of private networks existing altogether, it solves two very important problems. So the first is having poor internal protections, right? Having just poor internal network security. And if we predicate that we can have a private network where people within the network are allowed to be there, right? They've made it past the bouncer, then there isn't really a need for strict internal controls. But that's not always the case, right? And I think a great example of that is the 2014 Target hack, where hackers were able to enter Target's internal network, and they were able to traverse horizontally. Right? They went from HVAC data processing all the way to payments processing, and they stole a bunch of credit card information. Those two units, those two operations, entirely unrelated. You should not be able to go from HVAC data to payment processing. And so if you assume that the entire network is public, you're going to bake those controls in just by default, because you can't assume that anyone is safe. You have to assume that everyone might be a malicious actor. And the second advantage has to do with encryption, right? So like encryption best practices say to encrypt all the time, everywhere, end to end, right? Data in transit, data at rest, data in processing, just encrypt all of it. But again, if you can assume that the people in the private network have made it past some degree of security, scrutinization, those measures become a little bit more relaxed. But again, if you assume no private networks exist, then your default mode is to implement best practices. And the final principle has to do with centralizing your auditing and monitoring. And I like to think of logging as sort of like a hygiene habit, right? You could think of it as similar to like maintaining poor Git habits. If you have poor Git habits, then as you grow and as things get more complex, it's going to be more difficult to unravel that gigantic mess. And the same thing is true with logging habits. And nowadays, it's extremely important to make sure you centralize this now rather than later, because there's never been more logs to aggregate, right? Each progressive layer of abstraction creates its own set of logs. You have server logs, you have VM logs, application logs, container logs, Kubernetes logs. And every time you spin an instance, right, in an ephemeral instance, even for like 5 minutes, you basically create an entire like cross-section of the IT stack of logs. And it's very easy for that stuff to get lost in the noise because it's just for 5 minutes. So similar to identity, find a place to centralize all that information where you can aggregate, parse, analyze, dispose of, what have you, just in one place. And this is extremely important for DevSecOps as well, because DevSecOps is developer teams working with security teams, working with operations teams, right? And they need to be able to operate on the same information. There needs to be information symmetry. And so if you have all these logs that are siloed in their own locations, it's going to be very difficult to make informed decisions about what needs to be done. So centralize your logs. And another advantage I think is important mentioning has to do with compliance. So I think nowadays, like, compliance is almost a cost of entry into a lot of different markets, right? You have your SOC, your HIPAA, your PCI, your GDPR, and having some type of centralized logging and monitoring is, almost a prerequisite to pass those certifications. So, recapping just a little bit, right? The way to secure access to your infrastructure is by separating the processes of authentication and authorization and letting the resources themselves do the process or enforce those access policies. And to demonstrate this, I think for most of the remainder of this talk, I want to take these principles and apply them specifically to SSH certificates. Now, if you've worked with SSH at all, you know that common industry leaders or best practices will tell you that you should be using certificates instead of keys. That certificates are safer than keys. They're more reliable. And I think we all intuitively sort of know that to be true. But if we look at what makes SSH certificates safer through the lens of these 4 principles, it makes a lot more sense. So before we get into it, I just want to recap what certificates are. I think for the most part, we know all this, so I'll make it brief. But certificates are just a way to connect to a remote shell, right? They're just another, they serve a similar function as keys in that sense. But unlike keys, certificates have multiple properties. They have identity information, they have principals, they have permissions, they have expiry dates. And that's all metadata that keys do not have. And another advantage of certificates, or another sort of feature of certificates, is that you don't have to track the keys that are generated, right? All you need to do is track the certificate authority that creates those certificates. So instead of having this like laundry list of authorized keys or known hosts, all you need to do is have the public key for the associated certificate authorities. And you know that any certificate that has been signed by the paired private key is a valid certificate. It's something that you can authenticate against. And so then you can just easily, SSH using those certificates. And the process just, quickly as like a transition to the sort of like live demonstration, the process of using a certificate is to, 1, request a certificate from a certificate authority, right?
then the certificate authority will check its rules and make sure whether, or invalidate whether or not it is even allowed to issue you a certificate for what you're asking for. If it is, it'll sign a key and issue a certificate with all that metadata information. You will then present the certificate to the server that you're trying to SSH into. And at that point, the server will authenticate your user certificate, but your client machine will also authenticate the host certificate. And I want to demonstrate why that's important. So let's quickly jump into our demo environments. And so I've set all this up already. I have certificate authorities, I have certificates, and I've added the public keys to one another. So let's quickly see that. So here on my top terminal is my client machine. On my bottom terminal is my server machine. So in my client machine, we have the user certificate authority and its paired public key. We have keys that we have created and then certificates that we've signed with the certificate authority. Similarly, down here on my server machine, we have the host certificate authority and we have the host certificate authority associated public key. Now, both of these machines have the other's certificate authority public key known to them. So they know that anytime a certificate authority has signed a certificate with a private key, it can validate against that. It can validate that signature against the public key that is known to it. So on the server side here, we have the user certificate authority public key. And when it comes to our client machine, oh, what am I doing? This is the host certificate authority public key. And so this is how the machines know that whenever a certificate has been presented that has been signed by the appropriate certificate authority, you can authenticate. So let's do that. Let's see that in action. Well, the first thing I'm going to do is just take a look at my logs here. And SSH using the certificate. So we've done this successfully, right? We have SSH'd as the user Virag, and I want to highlight two things here. So the first is the authentication of the host certificate. So we can see here on my client machine that we have authenticated the host certificate that has an identity as example.domain.io, right? And this can be an IP address, this can be some type of like internal DNS system that you have running. And so this lets the client machine know that, hey, you can connect to the server. It is safe to do so. And similarly down here, we have the same thing, except the other way around, where the server machine knows that a user, Virag, has SSH using a user certificate that is valid. And the importance of this goes back to what I was saying about these private and public networks, right? That like private networks just don't exist. There's only public networks. And if you're able to authenticate both ends of the connection, then both these machines can exist on public networks, and it would make absolutely no difference. So looking more at these logs, we're seeing these names like Virag, my email is here. And so this is the identity information that I was talking about. So let's take a look at that. I want to highlight two that's the wrong command. I want to highlight two certificates. Here we go. Okay. So in this case, I have this is the certificate, the one that you're looking at right now. This is the certificate that I just used to SSH into our server here. And the two things I want to point out are this key ID and these principals. So your key ID is just the identity string. It's the ID string associated with the certificate. And your principal is a user that you are logging in as. And the reason that this information is important and valuable is because, you can set permissions based on this identity information. That's what I was saying earlier. So for Linux, like the simplest thing that you can do is grant pseudo rights to a user. And you can enforce that by using certificates because you have a principal that is logging in as that user, which you've identified has pseudo rights or doesn't have pseudo rights. So in this case, my principal Virag does not have pseudo rights, but in this case, my principal sysadmin does have pseudo rights. And you can script all of this too, right? Like none of this needs to be done manually. If you're using something like AWS Session Manager or using Ansible, you can have your certificates authority pull identity information and enforce the policies that you want. So let's take a look at that, right? Let's take a look at that in the logs. So I'm going to, well, let's take a look at the first time I SSH'd, right? I was able to SSH as user Virag, which has the ID Virag at gravitational.com. And so I know exactly the person and the group that they belong to. So what happens if this person tries to do something that they're not supposed to, right? What happens if I try and get pseudo rights? Well, you find out that, like I said, Virag does not have pseudo rights, and this information is reflected in the logs. Whereas if I were to log in as sysadmin, I do have those rights. So I can sudo, and now I have root. And again, all this information is reflected in the logs, right? So if you have this group sysadmin, you're like, oh, who is this person that just got root access to my server? Well, you can look back at the certificate and say, okay, this is the principal sysadmin, but I know that, oh, okay, it was Virag at gravitational.com. Let me go ask him what he was up to. And so this is how identity information is used to enforce your access policy. And so the more identity information you have, the more granular you can get with those policies. And so for the sake of this presentation, I think that's all I really have time for. And so I do want to quickly wrap up on this. And I like to do that by talking just a little bit about teleport. Please feel free to stay if you'd like to learn. So setting up an SSH certificate and setting up as like a certificate authority is just an absolute pain. I'm speaking from personal experience. And there are a bunch of like off-the-shelf solutions that do that for you. And so you don't need to go out and do it yourself. Teleport is one of those solutions. Teleport is open source. And it has all the principles that we just discussed earlier, right? So similarly, your certificate authority pulls identity information to enforce some type of role-based access control to all of your disparate cloud environments, and all that information is available for auditing in one place. And Teleport supports both SSH and Kubernetes. Like I said, it's open source, so feel free to go check it out. Download it if you'd like to, play around with it. If you don't have the time for that, just send us an email, and we're happy to set up a demo for you, personalized to what you guys need. So that's about it. I want to thank all of you for attending. Again, really appreciate your time. All of us are busy. If you'd like to learn more about Gravitational, you can check us out at gravitational.com. We have a pretty good blog, gravitational.com/blog, where you can learn about Teleport, about Gravity, and just about the industry as a whole. And if you'd like to follow us for updates, check us out on Twitter at Gravitational Co. It's Gravitational CO. Thanks, and have a nice weekend, everyone.